The line number one is the first metro project in Vietnam. So we Vietnamese government doesn't have the standard for the metro at this moment. We are thinking to consider the British underground section. I mean standard, the Russia standard, the Japanese standard, and the Germany standard to make our own standard. However, at this moment, we haven't got anyone yet. So to select the standard, we have some main consideration. The first one, this is the Germany standard because it's the donor standard, and we will receive the construction and the design from the donor. If we use another standard, different standard from the Germany one, can we utilize the experience of the constructor and the designer? This is the main question here. The second thing is, according to Vietnamese regulation, before the design step, we have to make the standard framework. It's like the roof to make the design. After the design, after the standard framework, we will do the design step by step to make the implementation. With the Vietnamese regulation, we will prioritize Vietnamese standard first. After that, we will prioritize Japanese and international standard. In case of conflict, the donor requirement will be revealed. So it is regulated, and we have nothing to say about this. We adopt solution like this. The first one, we will create the standard frame to be approved for the design. And if we have the Vietnamese standard, we will select it. In case we haven't got one, we will prioritize Japanese standard to utilize the familiarity of the consultant in the design. And I have to say that the design standard frame is not only the fixed frame. As it means that before you do the design, you have to submit it for approval. But the later detail, the later design step, if you need more standard, you should supplement it to make the more appropriate standard frame. And the solution is before the design step, we finalize the standard frame, and after that we carry out the design. If we find out and we want to supplement the design according to our task, depend on each task. It will be a huge task because Vietnamese regulation is very complicated. We need around 6 months to be approved for the standard frame. The next issue is the underground obstacle. With underground obstacle, I would like to say the building foundation and the underground system like telecommunication cable or the internet cable that crossing the area. According to our knowledge, there is 27 utility passing through and several old buildings in such as Bến Thành markets. And in fact, we lost some drawing or we don't have drawing of the building. You know that after the Vietnamese War, I mean in 1975, the American left and some of the technical drawing was burned, so that we could not see anything underground. And with each project, we just like do the trail excavation to see what below the ground, and then we do the construction. With the consideration in this issue, we will protect the utility first during the construction, and we consider the impact on local residents because it will create a noise and vibration, as well as it could stop some service like water supply, like electrical or internet connection. That's why we have to take care of the impact on local residents. And we also have to monitor the old building. Some of the building is about 100 years old. If you had visit the Chinatown of Singapore, you could see that what the old building is, and it's very similar to Ho Chi Minh City. It's just the same building. and if we touch the foundation, it might collapse. And because the media in Ho Chi Minh City now is quite strong, if we touch anything to the resident, it's a big problem for the project. The last one is the implementation schedule, and this is the most easy consideration to be dealt with. Now we have the solution as follow. We try to collect as much as possible the available information. We do it by create the stakeholder meeting. We could see the owner of each building, and then we try to make the geological survey real much more whole as possible. This is the first thing, and then we divide the utility into two groups. The minor utility like internet, telephone cable will be in one group, and we will assign it to a consultant or a contractor to do it. It's very easy. The second thing is the major utility, like the 1.2 meter diameter water supply pipe. We have to relocate it because it will supply the water for 4,000 households. And if we stop its operation, it will be the severe or create very inconvenient for the local resident. To deal with this one, we work closely with the Sawako, the water supply company in Ho Chi Minh City, and ask them to provide as much proposal on the detailed design as they could have, and then we propose the relocation plan for them. The third one, we will use the bottom-up construction. I would like to say that in the very first stage, we will use the TBM to carry out the channel of line number 1, but consider to build the USM, I mean the underground shopping mall, and the underground tip, we change to the bottom-up construction. With the bottom-up construction, we could identify the underground system as well as underground obstacle, and then we could pacify it. We also make it very officially by making a requirement in tender document. I mean that we put a sentence in the requirement that the contractor must do the trail excavation before using the machine to do it in mass scale. Now we come to the next issue. This is the anti-fire standard. We have to decide which anti-fire standard to follow. In Vietnamese, we are now following NFPA 130 standard. This is the American standard, but now it now belongs to the Japanese construction. So which standard we select? We have the background like this. This is the central area of Ho Chi Minh City. The station footprint or the land, the area consumption should be minimized as possible. We also consider the passenger and the station safety, and in case of fire, we would like to use the internationally recognized standard to provide as much as possible safety for the passenger. Now we have a quick look about some facts of the fire in around the world up to 2004. It's created in the handbook. We could see that we have a lot of fire in New York Metro, and it's in the USA, in Mexico, in Korea as well, and with the accident. We have 27 tons of fire, significant tons of fire, resulted in nearly 3,000 injured and 500 deaths. This number told us that the fire in the tunnel is very severe, and it could create a heavy damage for the people as well as for the infrastructure. Now I would like to have a quick summary about the NFPA 130 requirement. From when the fire occurs, the people from the platform will try to evacuate as soon as possible to the safety point, and from the platform to the concourse, the NFPA allow 4 minutes as much for to go to the concourse, and to the point of safety. This standard allow the interval of 6 minutes only. So this is a very easy requirement, but it play a heavy duty for the designer, because with the same amount of the passenger, they have to the designer have to calculate enough space for them to go into the point of safety. And now we will see different thinking of the Germany anti-fire standard. When instead of fire, the Germany standard take care or consider about the smoke. They use a curtain to stop the smoke and to maintain the vision for the passenger to run away. They request a 2 meter high for the clearance of the vision. And when the passenger go to the concourse or the more safer place, the curtain will close and isolate the fire. This is the main idea of Germany standard. So to adapt solution, we have to summarize the major difference between the two standards. You can see that with the evacuation time, the American standard, they say they need 2 points. It's the 4 minutes, and